Number one, we want to find the slope of the tangent line to y equal ln 5x plus 4 at x equal 1. So we first have to simply take the derivative, and then we're going to substitute x equal 1. The derivative gives us slopes of tangent lines at various points. All right, so let's take the derivative. The derivative of, let's just remind ourselves that, let's see, if y equal ln u, all right, then y prime is equal to 1 over u times u prime. All right, so we're going to do that here. We're going to do the chain rule. We're going to take 1 over the inner function. That's 1 over 5x plus 4. And the derivative of 5x plus 4 is 5. All right, now we just want to substitute in x equal 1. So let's say y prime. And here's some notation that means y prime at x equal 1. All right. Just substitute in 1, and we have 5 over 5 plus 4, or 5/9. Number 2, we want to find the derivative of this function. Now, since this is a log of something, we might as well take advantage of the log properties and expand, and then it'll be easier to find the derivative. So first, let's rewrite what y is. All right, so I'm writing that y is equal to, in the numerator we have a square root, so I'm going to bring down the 1/2 in front and write 1/2 ln x cubed plus 5. Okay, remember that's because square root is the same as exponent 1/2 in this expression. Now in the denominator, I'm going to subtract. Everything in the denominator we subtract. Okay, now I'm taking care of this. I'm bringing the 4 in front, 4 ln x, again using log properties. And again subtract because this is in the denominator, minus 5 ln x to the 4th plus 1. Okay, now it'll be much easier to take the derivative. Okay, so that's what we're doing now. All right, remember the chain rule. We put this in the denominator. And the derivative of x cubed plus 5 is 3x squared. So that goes here. And the derivative of ln x is 1 over x. And now we're doing the chain rule. Put x to the 4th plus 1 in the denominator. Derivative of x to the 4th plus 1 is 4x cubed. All right, so that's our derivative. In number 3, we have a product. Here's the first function is x cubed, and the second function is ln x squared. So we're going to do a product rule, differentiate using the product rule. So there we have the first function times the derivative of the second. Here we have a chain rule, bring down that 2 ln x to the 1. And the derivative of ln x, the derivative of the inner, is 1 over x. So far we did the first times the derivative of the second in our chain rule. And now the second part plus derivative of the first, that's 3x squared, times the second. In number 4, again, it makes sense to take advantage of the ln properties. We're going to expand. So we have y is equal to ln 7x squared plus 3 plus ln 5x to the 6 plus 2 plus ln 3x to the 8th plus 2. All right, now it'll be easier to take the derivative term by term, and that'll just be 7x squared plus 3 in the denominator, 14x in the numerator. Derivative of the next term, 5x to the 6 plus 2 in the denominator. And there we have 30 x to the 5th in the numerator. That's the derivative. And last term, 3x to the 8th plus 2 in the denominator, and derivative of this is 24x to the 7th, and that goes here.